Hello sir, my name is S.Siddharth and I am from section 16. My roll number is 21IM30019 and today for my DIY lab assignment 2, I will be showing you a fire alarm system that I made using the TinkerCAD website, TinkerCAD software. So this is the Arduino Uno R3. This is a microcontroller board and this is the main part of our whole setup. This is the breadboard. This is for connecting all the appliances. It has many pins and such. This is temperature sensor. It can detect the temperature. This is the gas sensor. It can detect concentrations of gas, and so it can also detect concentration of smoke, which is important for us. This can also detect temperatures, obviously, so fire, that's important. And this is a piezoelectric speaker. So I have coded it in such a way such that if the gas sensor detects concentrations above a certain amount, then this piezo speaker will buzz. And similarly, if this temperature sensor detects a temperature over a certain amount, this LED will light up. So I've set the limits as 65 degrees Celsius for this, and this is as 120 units. So that is relative to this, and this is a multimeter, and this is an oscilloscope. It is just to visualize the signals that are being sent to these appliances. And I've also added some resistors. So this is added so that the current which passes through these appliances is less. So if these resistors are not there, a larger current might pass and this might damage the device. So I've added one resistor to this and I added resistor to LED. And for the temperature sensor there is no resistance because it itself is a resistor. So that is how it operates. Yeah, and this multimeter is connected in parallel and this is connected in series. So the wiring, I will explain that. So this to this positive terminal, I've connected that to the 5-volt pin, and to this negative terminal, I have grounded it basically. I've sent it to the ground pin. So there's a potential difference of 5 volts. For the temperature sensor, one is connected to the 5-volt pin and the other is connected to the ground pin. And this wire, so basically the temperature sensor provides the calculates the temperature of the surroundings. So this calculation, this value is sent to this analog pin A0. So this Arduino board reads the temperature value through this temperature sensor. Similarly, for the gas sensor, I've connected to the 5-volt ports and the 0-volt ports, and one wire sends the reading of the concentration of the gas to this analog pin A1. So the inputs are read by the Arduino board, and if you look at the piezoelectric speaker, it is connected to digital pin 6 where that takes input from the Arduino board, and it is connected to the ground port so that we can complete the circuit. And similarly, this LED, one pin is connected to the ground port and the other pin is connected to the third digital pin number 13. It is also connected to an oscilloscope in series, as I've said before. So that is the wiring. So if I show you the code, you can see the blocks here. So these are variables, the gas sensor and temperature sensor. The readings are sent to the analog pin A1 and A0, and if the gas sensor reads a concentration of more than 120 units, the piezo speaker will buzz with tone 30 for 1 second. And if the temperature sensor detects a temperature of over 65 degrees Celsius, then the high output is sent to the LED bulb, which will make it glow. Otherwise, low output is sent. So this is the C++ code here. I added this one line, that is to convert the temperature to Celsius. Rest are created by the TinkerCAD software itself. By the way, this is a 1 kilo ohm resistor, and this is a 220 ohm resistor that I've also added it. And if I start the simulation, by the way, my laptop is not the fastest, so it may take a while. There is a lag, but that should not happen. It happens, so I will. So if I bring the gas cloud, that is the gas cloud. If I cloud of smoke, if I bring it closer, you can hear the buzzing of the speaker. The reading is also shown that shows that there is a current sent of 2.3, 2.3, 2.4 ohms, volts, 2.4 ohms. If I bring this far away, then The buzzing should stop instantly, but it takes a while, so it has stopped. Similarly, if I show the temperature is low right now, so there is no glowing and there is no signal here, as you can see. If I increase the temperature, just keep observing this bulb by the way. If I increase the temperature, it glows up. And now this oscilloscope should show a change. As you can see, it has shown a change. I will just show it again. If I bring this back, the it's not glowing and it's back to normal. So I will just show this again. If I bring the cloud up more closer, the piezo speaker is working. Buzzes and the voltage is seen. If I bring it back, it should stop buzzing right now. It should stop buzzing. Yeah, it has stopped. So that is the simulation. And I just want to say I had a lot of fun making these. I learned the workings of the temperature resistor, temperature sensor. Well, it's a resistor basically. This is a guy. Well, I learned the gas sensor also, the basic stuff, and I also connected this multimeter in series initially, but then it wasn't working. I tried the parallel connection because that is how we did in this lab, and that worked. In the school lab, we connected in parallel. I like that, and I also like this the code, the blocks. Basically, it makes it really simple to do stuff, and it's really easy. If you can just look at it, you can read and understand it like I did. So that was the simulation. I've stopped the simulation. So I already copied the code and I pasted it in I pasted it in Arduino. You can look at this C++ code and it takes the inputs and the thing reads it. It is read by the input is read, yeah, and if condition, and this is the line that I added the conversion. So if I give OK, and if I save it, I'll just save it. If I save the code, it is compiling. It's compiling. It doesn't take this long, but it does. It's taking now. So in the meanwhile, I'll just show this circuit. Yeah. By the way, this is limited to 120 units and this is of 65 degrees Celsius. Just added that and it is already compiled. It takes 2648 bytes, 2648 bytes. Maximum is much higher. Yeah, so that was it. I had a lot of fun making this. I like this TinkerCAD simple interface, but it is really effective. And yeah, that was it, sir. Thank you very much. Thank you. How do I stop? Okay.